everyone. Today we're going to be starting a new unit on functions. So a function is just an equation with an input and an output. You've been dealing with functions for a while, but we haven't been calling them functions. For example, f of x equals 3x minus 1 is a function. So x is the input. That's kind of hard to see. So x is the input, and f of x is the output. So f of x and y really are the same thing. You've been used to calling it y. Now we're just going to call it f of x and use a more formal notation. So let's try to find the output of our function if the input is 4. That just means we're going to input 4 or plug 4 into the function. So this is called f of 4. So f of 4 means that I'm going to take 4 and plug it in for x. So that is going to equal 11. Now let's try to find the output if the input is negative 1. So we're going to write that f of negative 1, meaning that we're going to take negative 1 and plug it in. So we get 3 times negative 1 minus 1, which is negative 4. Now let's go on to another example. So here my function is f of x equals 1 minus 2x. So that's really the same thing as y equals 1 minus 2x, where y and f of x are the same thing. So now we're going to take all these different numbers and plug them in. So first we're going to start with negative 3. So I'm going to take f of negative 3 and plug it into this equation. 1 minus 2 times negative 3. That's 1 plus 6, which is 7. Now I'm going to move on to negative 1. So I get f of negative 1 equals 1 minus 2 times negative 1, which is really 1 plus 2, which is 3. Now I'm going to use 0. So f of 0 is 1 minus 2 times 0, which is just 1. F of 2 is 1 minus 2 times 2, which is negative 3. One more, f of 4 is 1 minus 2 times 4, which is negative 7. So now I'm going to go ahead and plug these points into the graph. So remember that f of x and y are the same thing. So all of these values in this column are my y values. So I have the point negative 3, 7, the point negative 1, 3, 0.01 to negative 3, or negative 7. So here, I've graphed a line. So because this is a line, it's called a linear function. Let's try another one now. So here I'm going to take 4 different values and I'm going to plug it into my function f of x. So first, f of 2 means that I'm going to take 2 and plug it in where the x is. So I get 4 minus 3, which is 1. This gives me the point, the coordinate, 2, 1. Now let's try to do it with f of negative 1. So I get negative 1 squared minus 3. A lot of times kids have trouble when they're plugging a negative number into an exponential like this. So here, negative 1 squared is positive 1. Minus 3 is negative 2. Remember that negative 1 squared means negative 1 times negative 1. So I have the point negative 1, negative 2. Now let's plug in 0. So I get 0 squared minus 3, which is just negative 3. This leads me to the point 0, negative 3. One more. If I take 3 and I plug it in, I get 3 squared minus 3, which is 6. So I have the point 3, 6. Now let's go ahead and plot these points on our coordinate plane. I have point 2, 1, point negative 1, negative 2, 0, negative 3, and 3, 6. Now if you notice, these points do not form a line. If it's difficult for you to see what this graph would look like, you can always plug in more points. Plug in the point negative 3 or negative 4, that will give you a more clear picture of what you have here. But we're going to be dealing with these functions more as the year goes on. This is a parabola. And this is a quadratic function. Now let's talk a little bit about some more vocabulary words. So, the inputs or the x values of our function are called the domain. The outputs or the y values of our function are called the range. So now let's try to deal with the domain and the range of the function that's provided here. So all I have in this chart is just some x values and the y values that I got when I plugged those x values into the function. I don't have what the function is itself. But here our domain is just the x values that are listed here. So just -4, -2, 0, 2, 4, and 6. Domain is just x values. So I've just listed them in order from least to greatest. Now range is just a list of the y values. So now I should also try to order these from least to greatest. So that's going to give us -20, -4, 0, 5, 10, and 29. So you can also determine the domain and range of a function given the graph. So if we look at this graph that's given here, you'll notice that there are 4 points on the graph. So the domain is just the x values of those 4 points. So let's start with this point here. So that point's x value is -6. The next point that we see is this point, if you move along from left to right. The x value of that point is -2. This point has an x value of 1, and this point has an x value of 5. Now, let's look at the range. The range, let's start with our bottommost point. Our bottommost point has a y value of -3. If we move up, this next point we have, its y value is 0. This y value is 3. And this y value is 9. So all we're doing is listing the x and the y values of each of these points. If it helps you to write out what this point is, so this point is -6, 0. This point is -2, 9. This point is 1, 3. And this point is 5, -3. If you notice, the domain here is just what these x values are. -6, -2, 1, 5. -6, -2, 1, 5. If you need to write that out, go ahead. If you don't need to, that's fine too. So now let's look at this graph and let's decide what the domain and the range are for this graph. Here we don't just have a distinct set of points, we have a line. So if you look, the domain is just the x values that you get for our function here. So if you notice there are arrows on the end of this line, nope, that means that the line goes on forever in either direction. If the line goes on forever to the left direction, then I'm going to hit all values to the left. If the line goes on forever in the right direction, then I'm going to hit all values to the right. So here the x values that I get in my graph are -infinity to infinity. That's a little bit confusing. We're going to deal with this a little bit more tomorrow, so don't freak out just yet. Now the range here is the same thing because this line is going to continue up and down forever because of those arrows. So our range is also going to be -infinity to infinity. Now let's talk a little bit more about what a function has to do with inputs and outputs. So a function is an equation with an input and output. We talked about that already. And a rule for a function. If for each input there's only allowed to be one output. So if that rule is broken, then your equation is not a function. Let's talk about some examples to help make that a little bit more clear. Okay, sorry about that, a little bit of technical difficulty. So now let's look at these two examples. So let's decide whether or not this represents a function, this relation represents a function. So now, if you remember from the previous slide, we said that for each input, or for each x value, there's only allowed to be one output, or one y value. So here, for each x value, there's only one y value. That basically means that the y value can't repeat. So here, of our y values are different. There's no x value that goes to two different y values. So this is a function. Now let's look at this example. So here, if you look at the outputs that you have and the inputs that you have, this point and this point break the function rule because 2 has two different y values. If you plug 2 in, sometimes you get 3, and sometimes you get 0. That is what breaks the function rule. So this is not a function. Now let's try the same idea, but with a graph. So now, how you should be thinking about this is each x value can only go to one y value. So if you look along this graph, each x value that there is has only one y that goes with it. There's nowhere on this graph where an x value has two different y values that go with it. So this is a function. But now let's look at this one. So here, if you look at, for example, where x equals negative 2. When x equals negative 2, sometimes the y equals 4, and other times the y is negative 5. This breaks the function rule because that x, negative 2, goes to two different y values. It's also the case for any number between negative 4 and 2. Any x value in this range has two different y values that go with it. So this is not a function. We're going to continue with more examples of this tomorrow in class, so please watch the finish answering the questions. Thank you.